Hi guys, welcome to lecture series on data structure. This is Dr. Aarti from Kamaraj College of Engineering Technology associated with the Department of Information Technology. In this lecture video, we are going to discuss about one important ADT that is present in data structure, which is Stack ADT. This comes under a linear data structure. As we know, linear data structure has been classified into two major categories as linear data structure and the non-linear data structure based upon how we access the data and how it is efficiently stored in the memory. Looking into the linear data structure, the data has to be accessed in a linear manner, that is any data cannot be removed or inserted in between the given list. So that is what the linear data structure tells about. And in linear data structure, we do have stack implementation as well as queue, that is stack and queue can be used in order to implement this linear data structure. With that point, we will start with Stack ADT, which is one kind of linear data structure. This Stack ADT works with the principle of last in, first out. This is nothing but the element the element which is inserted last will be removed first. So, removed first, that is what last in, first out. So, a very good example of the Stack ADT is arranging the books in the table. So, when we arrange the book in the table, the book that we have arranged or kept at the last can be removed first. We cannot remove or we cannot take the book which has been placed first in the table. So, whatever book that we placed at the last can be taken first. So, that is a very good example of Stack ADT, and there are plenty of real-time example which can be used having the Stack ADT. So, looking into the implementation, let us consider this is a stack which can have n number of spaces to accommodate the data. So, if I am going to insert the value 10, so I am going to put a value 10. So, this 10 will be stored at the bottom of the stack, and this operation is what called as insertion. And in Stack ADT, every insert operation is said to be push operation. And if I want to remove, I can remove the element which is called as deletion operation, and in stack this is called as pop. So, when I am inserting 10, 10 is placed. The next time when we insert 20, 20 is placed. When we insert 30, 30 is placed inside the stack. Now, we have three elements and the element 10 is inserted first. This is placed at the bottom of the stack, and the element 30 is inserted last, which is placed at the top of the stack. Now, when we do the deletion operation, the element 30 is deleted because 30 is present at the top of the stack. So, this is what called as last in, first out. So, we can define the Stack ADT as Stack ADT is a linear data structure that works with the principle of last in, first out. It means the element that is inserted inside the stack as a last element can be removed first. So, that is what the definition of the Stack ADT, and this is the representation of stack where we said when we push something, the element which is pushed as a last element will be placed at the top of the stack, and when we pop the element which is present at the top of the stack will be popped out. So, this is the base concept of Stack ADT. Looking into the implementation of stack, the stack can be implemented either using an array or using a linked list. We would have watched our previous videos where we said the list ADT can be implemented using array or a linked list. So, list is nothing but a collection of data, and stack is of course a part and parcel of list. So, it is also having a collection of data. So, this Stack ADT also can be implemented using array or a linked list. So, we will be discussing both array as well as linked list with respect to the Stack ADT. Looking into the ADT, that is the abstract data type of stack, that is what are the operations that can be done on the stack, we can do some set of operations like push, pop, peek, isFull, isEmpty. We can do any kind of operation. We can do search, we can do traverse, So we can do n number of operations having with the stack ADT. Out of this, we will have a discussion of push, pop, peek, isFull, isEmpty with respect to array as well as with the linked list implementation. So let us go with an array implementation. So let us have a discussion of how to implement all these operations with respect to array. So let us first stick on to isFull and isEmpty. As we know, the array is a collection of similar data item where you have a restriction with the size. So you can store a specific amount of data in an array. So it is possible for us to do both the isFull operation as well as isEmpty operation. But before discussing this, let me tell one more thing about a stack structure. So when we saw this stack structure, the insertion and deletion operation will be carried out having with one important pointer which is called as top pointer. So there is a pointer called top which is going to handle both push and pop operation. So as we said about the structure of stack, so let us imagine this is a stack which is having some racks. Initially this top will be present out of the stack, and when we think about the array implementation, as we are going to see the array implementation, we will be having a stack with a fixed size. So this is a stack with fixed size. So as of this example is concerned, we have taken the stack which can hold 5 elements. We can hold 5 elements in this stack. So 5 is the maximum size. So we can tell n equal to 5, where n is going to represent the maximum size. So in our array implementation, we are going to take a variable called n which is representing as a maximum size, and in this case the array is having 5 elements, that is it can hold only 5 elements. This stack can hold 5 elements. Now as we said, there is a pointer called top which is present out of this stack. It means top is not pointing to 0, 1, 2, 3, 4, it is other than these values. So as of now, this space is taken as an index of -1. So when we go with the isEmpty implementation, so to check for isEmpty, we are going to find whether the value of top is -1. If the top value is -1, then it means empty stack. So whenever you want to check whether the stack is empty or not, it is easy for us to check having with the condition top equal to -1. If it is -1, it means there is no element in the stack. So that is what isEmpty tells about. Now let us discuss about isFull. Having with isFull, let us imagine we have some values here, 30, 40 and 50. As I said, the maximum size of stack is 5, and as of now we have 5 elements. Now instead of having top here, top will be moved to the location 4 because this is a value which we have inserted at last. So top will be moved from -1 to 50 by inserting each and every element. So after inserting 10, 20, 30, 40 and then 50. So when we are doing so, top value is also incremented. So when we are checking with isFull, we are going to check isFull. This has to be checked along with the n. N is going to tell about the maximum element in a list. So, if top value is equal to n minus 1. If top value is equal to n minus 1. Why we are telling us n minus 1? Because we know the array will start from 0 to n minus 1, where n is 5, and here we are checking for n minus 1, it is 4. If top is 4, it means the stack is full. So, here we can tell stack is full. So, these are the two easiest thing that we can do with the stack initially, checking for isEmpty, checking for isFull. So, let us quickly recap at this specific point. What we said about isFull is, if the top value is equal to n minus 1, that is the maximum limit minus 1, then stack is full. For isEmpty, if the top value is minus 1, it means there is no element in the stack, and the entire stack is now empty. The third one, which is peak. Peak tells about, so this is going to tell about the element which is present at top of the stack. So, whenever you have a stack, so let us imagine the name of the stack is A. In order to take the topmost element, so according to this specific example, 50 is the topmost element. Why we are telling this as a topmost element? Because this is an element which is pointed currently by top. So, the top of the stack is going to be the